Okay, for lecture 3, this first little mini video will be quite short. We'll just go over the definitions and properties of equality and translations, but those are just kind of the introduction to what we'll be doing. First of all, an equation is a statement setting two expressions equal to each other. Remember, an expression is just kind of a jumbled up mess of numbers and letters and operations, plus, minus, whatever. So an equation is just like that, but it's going to have an equal sign in the middle. So in other words, it's an expression with an equal sign. So here are three equations. We'll talk about solving them later, but for now, let's just talk about what the solution might be. I'm going to guess a solution for each one of these. So I'm going to guess that x equals 12 would work for the first. I'm going to guess that negative 23/3 would work for the second. And I'm going to guess that negative 3 would work for the third. So let's check. How do you check? Just going to take that number and plug it in. When I plug it in, try to remember to use parentheses. I'm sometimes not very good about putting them in except when they're absolutely necessary, but if you'll put them in every time, it will help. 12 minus 2 does equal 10, so yes, that is a solution. For the next one, 7 equals negative 23/3 plus 2/3. Well, that's negative 21/3. That's negative 7. Close, but no cigar. That's not a solution. Okay, next we'll put in negative 3. Those parentheses are vital. Put parentheses in whenever you're substituting in, especially when an exponent's involved. So negative 3 squared, that's different from negative 3 squared. Negative 3 squared is 9. Subtract 2 is 7, so that is a solution. A solution to an equation is just a value that makes the equation true. The solution set is the set of all values that make the equation true. For almost all of the class, until the very last day, you're only going to have one solution. Well, for the most part. But then at the very end, we'll get some that might have 2 or 3. A linear equation in one variable can be written as ax plus b equals 0, where a and b are numbers, a and b are coefficients. In other words, there aren't any exponents on the variables. That's the main thing to look for. So of the above equations, which ones are linear? First one's linear because it's just an x. The next one's linear because it's just a p. This guy is non-linear because of that x squared. We won't be solving nonlinear equations until the very last day of class. Okay, if two equations have the same solution set, they're said to be equivalent. So let's look at these three equations, and I know that these three equations look like they might be steps of solving a problem, and they are, but just pretend they are three separate equations for right now. Well, the solution set for this guy would be 12, because if I plug in 12, it makes it true. The solution set for that guy would be 12, because if I plug in 12, it makes it true. And the solution set for this guy would be 12, because if I plug in 12, it makes it true. So these are equivalent equations. And what you're actually doing when you're solving an equation is you're writing a series of equivalent equations. I know, they look like the steps for solving an equation, and that's what they are, but we're just finding a series of equivalent equations. Okay, so we've got our definitions. Properties of equality. Okay, I want you to think of a set of balance scales. We can get equivalent equations by adding the same thing to both sides. So if a is equal to b, then a plus c equals b plus c. This is called the additive property of equality. I abbreviate it by the plus sign and then POE for additive property of equality. So if I have x minus 2 equals 10, if I add 2 to both sides, think of balance scales. If I add 2 apples to both sides of a set of balance scales, they still balance. I get x equals 12. If I have p plus 2/3 equals 7, what would I need to do to solve this? Well, I'd want to get rid of that 2/3. I want p by itself. So I'd subtract 2/3 from both sides. 7 is the same as 21/3. So p would be 19/3. If I have negative 9 equals negative 21 plus b, I want to get b by itself, but there's a negative 21 that's being added there. But if I add 21 to both sides, I get b equals 12, and that would be the solution to that equation. These are all simple equations. These are what's called solving an equation that can be solved in one step. We can always check our work. Take 12 and plug it in. We get 12 minus 2 is 10. Take 19 thirds and plug it in. 19 thirds plus 2 thirds, that's 21 thirds, which is 7. Take 12 and plug it in. Negative 9 is equal to negative 21 plus 12, so all three of them check. So we get equivalent equations by multiplying the same thing to both sides. If A is equal to B, then A times C is equal to B times C. This is called the multiplicative property of equality. So let's solve and check these simple equations that can be solved in one step. 2w equals 8. I have 2 times w. Subtracting 2 isn't going to help me. I'd have to divide by 2 to get w by itself because the 2 is being multiplied. So divide both sides by 2. Think of a set of balance scales again. If I'm doing the same thing to both sides, it will stay equivalent. So I get w equals 4. Okay, 6 equals minus 2q. Oh, and my check. Plug it in, make sure it works. Divide both sides by negative 2. Adding 2 wouldn't help me. I'd need to divide by negative 2 because it's being multiplied, so I have to divide to get rid of it. What I do to one side, I've got to do to the other side. So I get q equals negative 3. I plug it into check, and it works. Now this one I know looks a little funny. Don't get scared of fractions. That's the reason I keep putting them in here, so you won't get scared of them. Negative 3/10 x equals 2/5. Well, if that negative 3/10 was not there, my life would be so much better. Well, what can I do? I could divide by negative 3/10. It looks gross, but I could. But an easier way is to just multiply by the reciprocal. So multiply by negative 10 thirds. So on the left-hand side, negative times negative is positive. 10 thirds times 3/10. Well, the 10 and the 10 cancel, the 3 and the 3 cancel. I'm just left with x. On the right-hand side, 5 goes into 10 2 times, so we have negative 4/3. Plug it into check, and it checks beautifully. Okay, those are our properties of equality. Let's solve some other simple equations that were, rather than given the equation, we're going to get the translation and then solve that. The sum of 31 and a number is 73. The sum, what do I write down? Plus the sum of 31 and a number is 73. 31 plus x equals 73. Subtract 31 from both sides, and x equals 42. 18 is equal to, so we have 18 equals sign, the quotient of a number and 2. Remember, quotient means divide. Now, how do I get x by itself? Remember, I can multiply the same thing to both sides. I'm going to multiply both sides by 2, get x equals 36. That's how I get x by itself. Those are the translations. Now we will, in the next section, we will go on to solving equations that take more than one step. Make sure you understand this one-step equations really well before moving on to the next section.